Hey guys, welcome to section 12.2 on arithmetic sequences. Today we're going to determine if a sequence is arithmetic, find a formula for it, and then find the sum of it. So first of all, what does it mean for a sequence to be arithmetic? That is if the difference between terms is always the same number. So if you were to subtract a term and its previous term, you would get a number we call D. And no matter what two terms you pick in the sequence, if they're directly one behind the other, and if you subtract them, you always get D, then that's an arithmetic sequence. Okay, so the way we define that is A sub 1, if we just call it A, then A sub n is going to be the previous term plus that D. That'll get you the next term. Okay, A sub 1 is the first term. D is called the common difference. Okay, so just another way to see it. A sub 1, the next term would be adding D. The next one would be adding 2 D's. And the next one would be adding 3 D's. Right? So you just keep adding D to get from one term to the next. Okay, so this is our formula for A sub n. It's A sub 1 plus n minus 1 times D, because you're adding D one less time than n. Okay, so number 1 says, find the 41st term of the sequence. So in the end, we're trying to find A sub 41. And I always like to write down like everything I have first so I can plug in stuff to the formula. So it looks like we definitely know A sub 1. That's going to be 2. And I think we also know D. D is that common difference. And if you notice from term to term, aren't we just adding 4 every time? Right? So the common difference would be 4. And then we want the 41st term, which means that n is going to be 41. And then just try to get as much information as you can, and then we're just going to plug everything in to this formula to try to find A sub 41. All right, so A sub 1 is going to be 2. And then we're adding the common difference n minus 1 times, so 41 minus 1. And then you're multiplying it times D, which is 4. And then this you can just do in your head or in the calculator. And we should get our answer. I'm getting 162 for the 41st term. Okay, number 2. So this one, we might be working backwards a little here. The 8th term of a sequence is 75. So I'm going to make my little list of what I know here. A sub 8 equals 75. And we also know the 20th term is 39. So A sub 20 is 39. We pretty much need to find everything else. We need n, we need D, and we need A sub 1. All right, so what I'm going to do first is actually try to find D. And to find D, I'm going to actually use like the slope formula. I'm going to do the change in y over the change in x to see what that constant rate of change is. Okay, so I'm going to do 39 minus 75 over 20 minus 8. Now there's multiple ways to do this step. So if you have a different way, by all means do it. This is just the way that I like to find D. So I'm calculating that and I end up getting negative 3 for D. Okay, so that's like our slope. That's our constant rate of change. And then I'm just going to use this formula to plug in everything I know to try to find A sub 1, right? Because we're trying to find the first term. Okay, So then what I'm going to do is I'm going to pick one of these to use. And why don't I just use this first one? All right, so a sub n for this term here, n would be 8, and a sub n would be 75. A sub 1 is what we're missing. Since we're using this term, n was 8, so 8 minus 1, and we know times d, we just said d was negative 3. All right, so if you guys can solve this, we can get a sub 1. All right, so I'm just going to work on that real quick. So it'll be 75. This is what? 7 times negative 3 is negative 21. So 75 plus 21 is 96. Okay, so a sub 1 is 96. All right, so find the first term, 96. Find the common difference, negative 3. And now find the nth term. So we need a sub n. All right, so for that one, I'm going to plug in everything we know into this formula to find the nth term. Okay, so a sub n equals a sub 1, which is 96, plus n minus 1 times d, which is negative 3. Now, we're not going to actually get a nice answer for this. We're just going to get an expression in terms of n. So if you just distribute and add like terms, we end up getting a sub n equals 96 minus 3n plus 3, which is actually 99 minus 3n. So that's going to be the nth term. Okay, so I think we're done with part A. And then part B, write a recursive formula. That's when you write a formula in terms of the previous term. So we would say a sub n equals a sub n minus 1. Okay, so the previous term. And then what are we doing each time to get the next term? Well, we're adding negative 3, or we're subtracting 3. So you just say the nth term is the previous term minus 3. That would be the recursive form. And I got that from up here. It's the previous term plus d. Okay, let's flip it over. Let's find the sums now. Find the sum of the first n terms of an arithmetic sequence. And then here's the good news, guys. We're going to give you all the formulas in this chapter, so you don't have to have this memorized. So the sum of the first n terms of an arithmetic sequence, you have 2 formulas to choose from. Whichever, and we'll give you both on the formula sheet, whichever one fits the information better, just use that one. Okay, so number 3, find the sum of the first 46 terms of the sequence. Again, I'm just going to write down what I have. I know that a sub 1 is 2. I also know d. What is the common difference? It looks like we're subtracting 3 every time, so d is going to be negative 3. I also know n because it says 46 terms. So n is 46. Okay, so if I have a sub 1, d, and n, I think I'm going to use this formula for this problem. All right, so let's plug in what we have. It's going to be n over 2 times 2 times a sub 1 plus n minus 1 times d. And then you can just type that straight in the calculator. All right, so let's make a fraction. 46 over 2 times 2 times 2 plus 46 minus 1 times negative 3. However you guys want to type that in, you should get negative 3013. All right, so pretty easy to just apply the formulas for these. Okay, same thing with number 4, except we're going to end up with an expression, not an actual number answer. So again, I'm going to list what I have. I know that a sub 1 is 8. All right, what's d? It looks like to get from term to term, we're adding 3. So d is going to be positive 3. And it also looks like we have the last term, which is a sub n. So that's 3n plus 5. That's what we have. So I'm going to use the formula that allows me to plug in these numbers here. So I think for this one, well, it actually doesn't matter. Why not on this one? I'm going to use this formula. It doesn't matter. Okay, so final answer, n over 2. We don't know n, so it's just going to be n over 2, times a sub 1 plus a sub n. So 8 plus 3n plus 5. And you would get the same answer if you use this formula. Doesn't matter. Let's just add like terms. It's going to be n over 2 times 3n plus 13. And you can leave your answer like that. Because we don't know what n is, so we can't actually solve it. All right, last one. Here we go. Number 5. Again, let's write down what we have. A sub 1, first term is 60. We can easily find out d. It looks like we're adding 4 every time, so d is positive 4. We also know the last term, which is a sub n, and that is 120. Okay. We actually, for this one, because it actually ends at a number, we can find n too. All right, so how could we find n? Well, we can plug all this stuff into this formula to try to find n first. All right, so remember this formula. A sub n equals a sub 1 plus n minus 1 times d. We have to find n first in order to get our answer. Okay, so let's plug in what we know. A sub n is 120. A sub 1 is 60. N we don't know. And d is 4. All right, so go ahead and solve that for n. That would be 60 equals 4 times n minus 1. So 15 equals n minus 1. So n would be 16. Okay, so that's really helpful because to use our sum formula, we need n. Okay, so final answer, the sum is going to be, and you guys pick which formula. I'm going to pick this one because it's shorter. So n over 2 times a sub 1 plus a sub n. So n is 16, so 16 over 2 times a sub 1, which is 60, plus a sub n, which is 120. And if you calculate that, that will be your answer. So that's what, 8 times 180, so that's 1,440. All right, awesome. So it's just a lot of like manipulating the formulas to get what you need to find the answer. All right, thanks for watching, guys. That's it for 12.2, day 1.